In this video, we're going to learn how to evaluate trigonometric integrals involving powers and products of tangents and secants. Just like with powers of sine and cosine, the method we'll use will depend on the powers in the integrand, and we'll use trigonometric identities to rewrite the integral into a form that's easier to integrate. We're going to start by deriving the formulas for the integrals of tangent and secant. Then I'm going to teach you how to handle powers of tangent and secant by looking at different cases depending on whether the powers are even or the powers are odd. We'll then look at products of tangent and secant and develop steps that you can follow depending on whether the tangent power is odd or the secant power is even. We'll work through examples of each case so that you can see exactly how the methods work. Let's get started. We're first going to learn how to derive the formulas for the integral of tangent and the integral of secant. It's really good to walk through these two problems so you can see where the formula comes from and then remember how to get it in case you forget the formula. The first one that we'll look at is the integral of tangent x. The key to integrating tangent x is to first write it as the integral of sine x over cosine x. We can then use u-substitution and let u be equal to cosine x. The reason that we're doing this is that du then is minus sine x dx, and we have that in the numerator. Let's go ahead and plug this in. This gives us the integral. We have to watch out for the minus sign. We have a minus du all over u. We know how to integrate that. That's just minus natural log absolute value of u plus c. We now go ahead and plug back in that u is equal to cosine x. So we have natural log absolute value cosine x plus c. We're not done yet because what's customary is we're going to take this negative sign right here and we're going to put it in the power. And we can do that because of the properties of the natural log. This then becomes the natural log absolute value cosine x to the minus 1 plus c. And we know that 1 over cosine is equal to secant. So we can write this as the natural log absolute value secant x plus c. And there's our answer and our formula. Let's now look at our second example. We are going to integrate secant x dx. The key to integrating secant x is to take secant x and multiply both the numerator and the denominator by secant x plus tangent x. And you really have to see this problem once to know that that's what you have to do, because this does not feel natural at all. I'm going to actually highlight this so that you can remember this part, because that's the hardest part. Now let's go ahead and let's just multiply through. This gives us the integral. In the numerator, we have secant squared x plus secant x tangent x. And then in our denominator, we just have secant x plus tangent x. Now you can probably see why we actually did this. We're going to let u be equal to secant x plus tangent x. And then let's see what du is. Du is the derivative of secant, which is secant x tangent x, plus the derivative of tangent x, which is secant squared x. And let's multiply all this by dx. Notice that this derivative is right up here in the numerator, and that's exactly why we did the multiplication that we did at the beginning. Now we'll flip to everything in terms of u, so we have the integral of du all divided by u. That's the natural log absolute value of u plus c. And then we just plug back in what u is. U, let me go ahead and let's highlight that in pink so you can see what I'm looking at. It is secant x plus tangent x plus c. And there's our answer and our formula. You may want to memorize these formulas, so I went ahead and put them down here in this green box just to make it easier. Let's now learn how to integrate powers of tangent. These integrals look like this, where m is the power of tangent, and m can be either even or it can be odd. The first case that we're going to look at is when we're integrating a power of tangent and the power is even. In our first example, we are going to integrate tangent squared x dx. To integrate tangent squared x, we are going to need to use the trigonometric identity that I wrote over here on the right. Tangent squared is equal to secant squared minus 1. The reason that we have to use this identity is we know the integral of secant squared, but we don't know the integral of tangent squared. Let's go ahead and let's make this substitution. We have the integral of tangent squared is now the integral of secant squared x minus 1 dx. We can just go ahead and integrate that. Integral of secant squared is tangent x. And then we subtract off the integral of 1, which is x. And then we add on our arbitrary constant. And there's our answer. For our second example, we are going to integrate tangent to the fourth x dx. This one's a bit complicated, so I wrote down 3 steps that we can follow, and I'll walk through these steps one by one as we work through our example. Let's go ahead and let's write down the problem. We're integrating tangent to the fourth x dx. Step 1 tells us to pull off tangent squared x. Let's go ahead and let's do that. I'll label this step 1. So we have the integral. If we pull off 1 tangent squared x, we have a tangent squared x left. Now let's talk about why we're doing this. The reason that we're doing this is that we can take this tangent squared x that we just pulled off and rewrite it in terms of secant squared, and the derivative of tangent is secant squared. That's explained up here in step 2. We're going to use tangent squared is equal to secant squared x minus 1 to rewrite our tangent squared that's highlighted down here in pink. Let's go ahead and let's do that. We have the integral tangent squared x, and then now the tangent squared that we pulled off can be written as secant squared x minus 1 times dx. We really have 2 integrals here, so let's go ahead and multiply this out. We have tangent squared x secant squared x dx minus the integral tangent squared x dx. Let's go ahead and let's work on the integral on the right first, because this integral on the right is also an even power of tangent, and we're going to do the same thing. We are going to take this tangent squared right here, and we are going to rewrite it as secant squared x minus 1 dx. And then let's go ahead and let's just integrate this. This is minus the integral of secant squared is tangent x, and then the integral of 1, or minus 1, is minus x. So let's go ahead and let's multiply this negative through. So this is minus tangent x plus x. I'm going to highlight this, and we are going to put that in our pocket and hold on to that until we finish the first integral. Let's now go back up to the top and let's look at step 3. We are going to let u be equal to tangent x, and then we'll integrate using u-substitution. We'll put a 3 down here. So we're going to let u be equal to tangent x. We are referring to this integral right there. and then du is equal to secant squared x dx. We'll draw an arrow here so you can see where we are. We have now the integral tangent squared, so that's u squared, and then secant squared x dx is du. So this becomes u cubed over 3, and then u is tangent, so we have 1/3 tangent cubed x. And that's our first piece. Now all we have to do is combine these two answers. So we have the integral tangent to the 4th x dx is equal to 1/3 tangent cubed x minus tangent x plus x, and then we add on our arbitrary constant c. And there's our answer. The second case that we're going to look at is when we're integrating an odd power of tangent. The example that we'll walk through is tangent cubed x, and notice that 3 is odd. I've written down steps that we can follow, and we'll walk through these one by one as we work through our example. Our first step is to pull off tangent x, just one of them. Let's go ahead and let's do that. We have the integral tangent cubed x dx. So our first step is to rewrite this, pull off one tangent x, so that leaves us with tangent squared x times tangent x dx. The reason that we're doing this is this leaves an even power of tangent, and we can rewrite that in terms of secant squared, and the derivative of tangent is secant squared. I wrote that up here in step 2, and that's what we're going to do now. We are going to take the tangent squared that I have highlighted in blue and rewrite it as secant squared x minus 1 times tangent x dx. Now let's go ahead and let's make this two integrals. Our first integral, we have secant squared x times tangent x dx, and then we have minus the integral tangent x dx. For this second integral, we can just use the formula. The integral of tangent x is the natural log of absolute value secant x. You just get that by rewriting tangent as sine over cosine and then use u-substitution. Now we have to evaluate our first integral. Let's look up here to step 3. Step 3 says that we are going to let u equal tangent x and integrate using u-substitution. Our u is tangent x, and then our du is secant squared x dx. So this gives us the integral of u du, and this is just u squared over 2. We'll bring the 1/2 out in front, and then we just plug back in that u is tangent x, so this is 1/2 tangent squared x. Now we have two pieces, our second integral and our first integral. And then let me highlight this negative because that has to carry through to the second integral. And we can go ahead and write down our answer. The integral of tangent cubed x dx is just 1/2 tangent squared x minus natural log absolute value secant x plus our arbitrary constant c. And there's our answer. Let's now learn how to integrate powers of secant. These integrals look like this, where n is the power of secant, and n can be either even or odd. We're first going to look at the case when the power of secant is even. And we're going to look at the example, the integral of secant to the 4th x dx. I've written down steps that we can follow, and we'll work through these one by one as we walk through our example. Our first step is to pull off secant squared x and group it with dx. We have the integral secant to the fourth x dx. And our first step is to pull off a secant squared, so we have a secant squared x left. And then we have a secant squared x that we pulled off, and our dx. The reason that we're doing this is we have an even power of secant left, and we can change that secant to tangent, and then the derivative of tangent is secant squared, which we have right there. This is exactly what step 2 tells us to do. In step 2, we're going to rewrite our secant squared x that I have highlighted in blue, and we're going to rewrite it as 1 plus tangent squared x. I wrote that up here on the right in this green box. And then we have our secant squared x dx. Let's go ahead and let's make this into two integrals. Our first integral is secant squared x dx. And then our second integral is tangent squared x secant squared x dx. This first integral we can go ahead and just write down because that's a formula that we know. The derivative of tangent is secant squared, so the integral of secant squared is just tangent x. Plus, and then for the second one, we have to go back up here to the top and look at step 3. We are going to let u be equal to tangent x and then use u-substitution. Over here, let's write our step 3, and we're going to say u is equal to tangent x. Du is equal to secant squared x dx. Now our integral becomes the integral tangent squared x, so this is u squared times secant squared x dx, which is du. We know this integrates to 1/3 u cubed. Our u is tangent, so this is 1/3 tangent cubed x. Now let's go ahead and let's combine our answers. So we have the integral secant to the fourth x dx is equal to tangent x plus 1/3 tangent cubed x, and then we add on our constant c. And there's our answer. The second case we're going to look at is when we're integrating an odd power of secant. The example that we're going to look at is secant cubed x dx. I've written down steps that we can follow, and we'll walk through these one by one. Our first step is to pull off secant squared x and group it with dx. Let's go ahead and let's do that. We have the integral secant cubed x dx. And in our first step, we are going to pull off a secant squared x and group it with dx. So that leaves us with 1 secant x, and then we have secant squared x dx. The reason that we're doing this is a bit complicated, but let me walk you through this. To solve this problem, we are going to have to use integration by parts. Don't worry, I'll walk you through it. When we use integration by parts, we need a dv that we can integrate, and notice that we can integrate secant squared x. It's just going to be tangent x. And that's exactly why we had to pull off a secant squared x. Let's go back up here to the top and look at step 2. It says to integrate by parts using dv is secant squared x dx. So we'll put a 2 down here. We are going to let u be equal to secant x, and then dv be equal to secant squared x dx. Du is equal to secant x tangent x, and we can't forget our dx. And then v is the integral of secant squared, which is just tangent x. Up here on the right, I put down the formula for integration by parts in case you've forgotten it. And let's go ahead and let's apply that formula now. Our integral is equal to uv, so this is secant x tangent x, minus the integral v, which is tangent x, times du, which is secant x, tangent x, dx. Let's now focus on this integral on the right. Let's rewrite this because we can combine the tangents. So this is tangent squared x times secant x dx. Now we have to think about what to do. The derivative of secant is secant tangent, so that's not going to help. The derivative of tangent is secant squared, so that's not going to help. So let's see, what else could we do? We could change our tangent squared right here into secant squared. What would that give us? Let's see. If we changed it into secant squared, we would get a secant cubed, and then we could combine that with our original integral. So that's what we're going to do. We are going to make the substitution. Tangent squared is secant squared x minus 1, and we multiply that by secant x dx. So this becomes minus the integral secant cubed x, and then we have a minus and negative, so this is plus the integral secant x dx. Now let's go ahead and let's combine everything. I'm going to write down the integral secant cubed x dx is equal to our u times v, which was our secant x tangent x. And then we have minus the integral secant cubed x, and I just realized I forgot the dx there. And now we're going to add on the integral of secant x. We know what that is. It's a formula. It is the natural log of the absolute value of secant x plus tangent x. We're going to hold off on the plus c until we get done. We're going to take this integral and combine it with this one. So we have 2, the integral secant cubed x dx. And what we have left is our secant x tangent x plus our natural log absolute value secant x plus tangent x. This is why Calculus 2 is such a hard course. Now all we have to do is divide by 2. So we have secant cubed x dx is equal to 1/2 secant x tangent x plus 1/2 natural log absolute value secant x plus tangent x. Now we add on our plus c. And there's our answer. I know this was hard, but working through problems like this are really good because you are learning how to recognize patterns, decide what to do, and this develops problem-solving flexibility that you can use in all your future courses. We are going to learn how to integrate products of tangent and secant. These integrals look like this, and m is the power of tangent and n is the power of secant. We're going to look at 2 cases, one where the tangent power is odd and the other where the secant power is even. We'll begin with case 1 where the tangent power is odd, and the example that we're going to look at is the integral of tangent cubed x, notice the 3 is odd, times secant cubed x dx. I've written down some steps that we can follow, and we'll work through these one by one as we walk through this example. Step 1 is to pull off one tangent x secant x and group it with dx. We'll do this, and then I'll show you exactly why we're doing this. We have the integral of tangent cubed x times secant cubed x dx. And our first step is to pull off a tangent x secant x. So that leaves us with tangent squared x, secant squared x, and then here is our tangent x secant x that we're grouping with dx. The reason that we're doing this is that the derivative of secant is secant x tangent x, and we can make powers of secant by changing our tangent x to secant x. That's exactly what it tells us to do in step 2. So let's go ahead and let's do that. Step 2 says we are going to use our identity to rewrite our remaining powers of tangent in terms of secant. So tangent squared x is secant squared x minus 1. And then we have secant squared x. And then our derivative, tangent x secant x dx. Let's go ahead and let's rewrite this. This is secant to the 4th x minus secant squared x. And then we have our tangent x secant x dx. Now let's look at step 3. You might already be guessing what this is. We are going to do a u-substitution, and we're going to let u be equal to secant x, and then we'll just integrate. So for step 3, our u is equal to secant x, and our du is secant x tangent x dx, and we have that up there. So this becomes the integral of secant to the 4th, so that's now u to the 4th, minus secant squared is u squared, and then we have our du. This is a nice one to integrate. This is just 1/5 u to the 5th minus 1/3 u cubed plus our arbitrary constant c. We're not done. Don't forget that we have to flip everything back in terms of our original variables. Let me highlight up here. Our u was secant x, so we now have 1/5 secant to the 5th x minus 1/3 secant cubed x plus c. And there's our answer. So let's review real quick. Just remember, when you have an odd power of tangent, you are going to pull off 1 secant x tangent x. We'll now look at integrals of powers of tangent and secant when the secant power is even, and the example that we're going to walk through is tangent to the 4th x secant to the 4th x, and that has an even power of secant. I've listed steps that we can follow, and we'll start with our first step, which is to pull off secant squared x. Let's highlight that and group it with dx. Once we do this, I will tell you exactly why we're doing this, but it's easier if I can show it to you. Tangent to the 4th x, secant to the 4th x dx. Let's give ourselves some more space. And our first step is to pull off secant squared x. So we have tangent to the 4th x, we have secant squared x, and then the secant squared x dx that we pulled off. Now, the reason that we pulled off this secant squared x is that the derivative of tangent is secant squared, and we can rewrite this secant squared in terms of tangent, and then we'll have our derivative. That's exactly what I highlight here in our second step. We're going to use the identity secant squared is 1 plus tangent squared to rewrite our secants in terms of our tangents. Let's do that. Our tangent to the 4th comes along for the ride, and then our secant squared is now 1 plus tangent squared, and then we have our derivative secant squared x dx. For step 3, we are going to use u-substitution, and we're going to let u be equal to tangent x, and then we'll just integrate. Before we do that, I just think we ought to rewrite this. So this is going to be tangent to the 4th x plus tangent to the 6th x times secant squared x dx. Some of you may be able to do this without u-substitution, but I just want to be really thorough and show you exactly how this works. So u is equal to tangent x, and then du is equal to the derivative of tangent, which is secant squared x dx. So we can rewrite our integral as tangent to the fourth, so that's now u to the fourth, plus tangent to the sixth, which is u to the sixth, and then secant squared dx is just du. We integrate this. This is 1/5 u to the fifth plus 1/7 u to the seventh plus c. And then don't forget, our last step is we have to switch back to our original variable. Let's go hunting here. Let's see, where is that? Right here. U is equal to tangent x. So this is tangent to the fifth x plus 1/7 tangent to the 7x plus c. And there's our final answer. And that's it. You've now learned how to evaluate trigonometric integrals involving powers and products of tangent and secant. The key is to first look carefully at the integrand and recognize which case you have. The more problems you work, the easier it's going to be to recognize which case you have and how to solve that case. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.